Is Dr. Orain Brown. So Orain is a postdoctoral research fellow in the Department of Chemistry and also Chemical and Materials Engineering at the University of Alberta. And Orain completed his PhD in chemistry with a focus on catalysts relevant to crude oil upgrading. So we are happy to have you here today to discuss about processing.
All right, so today I'd like to look at what's in your gas tank and just to sort of get a feel of the processing that goes into filling up our gas tank when we pull up to a gas station. So I don't know if anybody's been to a gas station recently. I know I have, and I paid a whole 136 cents a liter. So the question is, what are you really getting when you pull up to the pump and fill your gas tank? Well, the first thing I'd like to call your attention to is that almost all pumps will have this notice saying that the fuel contains up to 10% ethanol. And that's because the fuel that we have currently is a mixture of biofuels and fuels from hydrocarbon sources. I'd just like to look briefly on the processing that goes into both of these segments of fuels. I'm going to start off with biofuels and then I'll look at the hydrocarbon sources. Now, the biofuels that we use are in gas that's blended into gasoline is mostly ethanol. And ethanol starts out at a number of facilities in the Canadian context, at a number of facilities all across Canada. And I have this map up here just to show you some of the main sites where ethanol is produced. Now, you see these icons on screen looking like corn or wheat. And I've done that because those are the major sources of ethanol in Canada and in North America, in that corn and wheat are converted to ethanol, which we end up using in our gas tank. I'd like to call your attention to the little car in Edmonton, but just beside it, there is a recycling sign because there's one facility in Edmonton here that's first in the world that doesn't rely on, agricultural products, but actually is turning municipal waste into ethanol. That's Enerchem here in Edmonton. I won't talk too much about that. I just want you to be aware of it. So we use quite a bit of ethanol, about over 3 billion liters a year in Canada we use in our cars. Most of that is sourced domestically, but some is also imported from the US. And the key thing is that the use of ethanol is on the rise because the federal government and provincial governments are trying to incorporate more renewable fuels into the fuel mix in order to reduce emissions. So how do we turn corn and wheat into ethanol? Well, this is a very, very old process. And anybody who enjoys a glass of wine will know a little bit about it. So essentially what we need is that we take, a starch, like say corn. We take corn which contains starch. And what you need to do is to find some way to break that starch down into simpler molecules. And the simplest molecule of them all is glucose. Now, once you get glucose, all you need is yeast, as anybody who's done some home brewing knows, and the yeast will convert the glucose into ethanol, and then we're well on our way. In terms of on an industrial scale, the first step in processing corn and wheat into ethanol is milling, so we grind it. And then you add water and cook. And the point of that, the cooking and then what's called saccharification, which is essentially breaking the starches down into sugars, right? So those are the first key steps. Following that, once we have our simple sugars, we can introduce the yeast into the mixture. And the yeast now converts the sugars to ethanol. Now, the ethanol you get after fermentation contains quite a bit of water, and we don't want to be putting water into our gas tanks. So then we need to go through a process that's called distillation, which is essential to separate ethanol from water. The ethanol that you get after distillation is essentially 100% pure. sounds very tempting, and there's a worry some might get diverted into the consumer, liquid drinking market. So what happens is that ethanol is then denatured, which is essentially you add chemicals to usually dyes or chemicals to make the ethanol extremely bitter, just to discourage anybody from taking a sip from the fuel ethanol taps. So once you've denatured the ethanol, then all that's left to be done is put it on a truck and transport it to your refinery, where it's going to be blended with gasoline. And then it's sent to your gas station, where you can pay 136 cents a liter for it. Now, using ethanol as a fuel has a lot of benefits. The most obvious is that it's a biofuel. If we're sourcing it from plants, we can always grow more plants. So it has the potential to have a zero carbon impact. Not quite, but it has the potential to. It reduces our dependence on fossil fuels. Every liter of ethanol we're using is a liter of gasoline that's not being used. It's also a very important component for us in Canada in terms of meeting our emissions reduction targets, right? So, the more biofuels we use, the less net emissions we have going into the atmosphere. And we can source this from many raw materials. We can use corn, wheat, in some countries, sugarcane. And it has the added effect, because we're using these commodity materials, of ensuring that you get stable prices for grains for farmers and so on. But this is a double-edged sword, because, of course, if we're using an agricultural commodity, that's going to be competing with food sources. So it's been reported that just over a quarter of all of the corn that's planted in the United States and Canada is converted to ethanol for fuel. And so that means that those persons who need corn to eat, livestock or human beings, of course, are going to end up competing with, ethanol for corn for fuel. And so that drives up the prices. And then ethanol is not as energy dense as petroleum. So you get less energy out of a liter of ethanol as opposed to pure gasoline. And ethanol is not completely carbon neutral, because quite a bit of fossil fuels have to be used in growing the crops, processing, distilling, and transportation. So it's not exactly free of fossil fuels, but it still has its benefits. Now, we want to look at the other side of the gasoline equation, and that's the hydrocarbon side, which makes up the majority, the major part of the gasoline that you put into your tank. So we want to look a little bit of that. And we're going to look mostly at it in the Alberta context, because most of the hydrocarbon fuel that we get comes from bitumen, which is sourced from the Alberta oil sands. So we're going to look at it in that context. Now, as you see here highlighted in pink in this diagram on the left, that oil is distributed in Canada. It's mostly in Western Canada, and Edmonton is a central point for processing and transshipment of much of this oil that's produced in Western Canada. As you see, most of it comes from just north of Edmonton here, and most of the pipelines converge in Edmonton. And here in Edmonton, with all those pipelines converging here, transporting oil, it's quite natural that there are going to be quite a number of refineries. And what these refineries essentially do is that they take crude oil and they separate it into its various components, right? So there are 4 refineries in the Edmonton area, and these refineries together process about 400,000 barrels of crude oil every day. So essentially in Edmonton, we're producing enough fuel for 1 million gas tank fill-ups every single day. So quite a bit of fuel is being produced. And as we see on the right, the vast majority of crude oil that comes here is converted to either gasoline and diesel along with other products. Now, the question is, what happens in these refineries? Well, it's simple, really. What you do is that you take the crude oil that's delivered by all these pipelines converging in Edmonton, and you feed it into a furnace. And that furnace is heated to a very high temperature. And what that does is that it causes the crude oil to boil, right? So it evaporates. And then that vapor is fed into a tower, and that vapor rises because we know that hot air rises. And as that vapor is rising, the different fractions that are in crude oil begin to cool at different temperatures. And so there are collectors, at different zones in this cooling tower. And so different fractions are collected. And the fraction that we're most interested in is close to the top here, gasoline, which boils at about 25 to 60 degrees Celsius. Now, it's not quite as simple. There are other processes that are taking place. I just described for you fractional distillation. But in addition to that, there are processes such as cracking, which if you have very large molecules in your crude oil, you can break them into smaller ones. There's hydrotreating. And what this does is that it removes sulfur and nitrogen, which are very noxious pollutants if they get burned in your gasoline. And there's another process called catalytic reforming, which is essentially changing the structure of molecules so that the fuel quality is much better. There's some special requirements as far as Alberta's oil is concerned. So ideally, you just want to take crude oil and send it to a refinery to do the process that I just mentioned. But with Alberta Oil, there is a catch. And the catch is that Alberta oil is rather viscous and dense. So if you look at this graph here, it looks complex, but essentially what I want you to pay attention to is that this is Alberta oil. It's a measure of the density and viscosity of Alberta oil. It's put together in this descriptor that's called API. So Alberta oil has a low API, about 7 to 10, right? Now, in order for the oil to be put into a pipeline, it has to have a minimum API of 19 or 20. So the oil that we have is too viscous, too dense to be put into a pipeline. So what has to happen is one of two things. The simplest thing to do is we just dilute the oil. We add a solvent, it's diluted, and then we can put that into a pipeline and send it to a refinery. The other option is something that's called upgrading, which is essentially you do some processing on the oil that either removes carbon or removes some components of it. And the result is that you get a product that is less dense, less viscous, so that now can be transported in a pipeline to refineries to be processed. There are challenges with both of these in that there are costs that are added. If you need to put extra diluent or if you need to do upgrading, then you're adding lots of cost. And in the case of upgrading, it requires fairly high temperatures. So you're adding some greenhouse gases to the process. But we need to do that in order to get the oil to market. So if we look at a more realistic flow of what happens to Alberta oil, essentially we start with our oil sands deposits. We get to the first step is extraction that was discussed in an earlier session. Once you have extraction, you get this bitumen that, as I mentioned before, has an API of around 7 to 10, dense and viscous. So what do we do with it? The first thing is that we send it to tanks to be diluted. Now, once this bitumen is diluted, it flows much better. And as you see here, the API changes to 20 to 22. So it's less dense, less viscous. So that diluted bitumen, you can do one of two things to it. You can either send it in a pipeline directly to a refinery, and then the refinery can take that diluted bitumen and process it into fuels, or you can send it to a facility that's called an upgrader. And in the upgrader, what you do is you remove the diluent and recycle that, and then you process the oil just enough that it can flow nicely in a pipeline. This oil is now called synthetic crude oil, and that synthetic crude oil is then sent to a refinery to be finally processed into gasoline. So as you can see, the process can be quite involved, but eventually, once you do either dilution or upgrading, you come back to this fractional distillation so that you can get your gasoline from crude oil. Of course, there are benefits and challenges with everything. So with fossil fuels, they're nice because they have high energy density, they're widely available and easy to ship and store. But we know that these are non-renewable fuels and they contribute to CO2 emissions, and they have significant environmental and land impacts. So that's something that's to be concerned about. But I'll come back to where we started. I hope now you have a good grasp of when you go to the gas tank, all the work and processing that goes on behind the scenes, so that you have the privilege of paying 136 cents a liter for your fuel. So with that, thank you very much, and I'll hand back to the moderator.